The second method is using the standard enthalpy of formation. And I've written out the equation below. One thing I wanted to note is the question is asking for the molar heat for the complete combustion of ethane. So that's why fractions were used, because we are specifically looking for the delta H for the combustion of 1 mole of ethane. So this method, remember, we take into account the mole ratios. So for the products, we have 3 moles of water vapor, and water vapor has a delta H of negative 241.8 kilojoules per mole, plus 2 moles of CO2, negative 393.5 kilojoules per mole times 2, minus your reactants. So 1 mole of your ethane, which is negative 83.8 kilojoules per mole, plus, and remember, oxygen gas in its standard state will have delta H of 0. So we can cross this out entirely. So negative 241.8 times 3 plus 2 times negative 393.5 is negative 2,963.2 kilojoules minus negative 83.8 kilojoules. Oh, sorry. The first one is not this number. The first number is negative 1,512.4 kilojoules. I just double checked on my calculator. And you're going to take that negative value and plus 83.8. So negative 1,428.6 kilojoules. Because it is an addition of values in this step, we're going to use the final decimal value amount for our final answer. So final answer is 1,428.6 kilojoules. So if you notice, negative. If you notice and compare both of these numbers between standard enthalpy of formation method and bond energies method, there is a discrepancy, and that is because bond energies, so using our first method, the bond energies given in your reference table are only estimated values due to the use of energy averages. So these bond energies take into account many different kinds of molecules with these bonds. And so, again, they're only averages for your bonds. Okay, so that is why we have kind of a difference in value between the two methods. Example 4 is comparing bond energies and solving for molar heat, again, for 1 mole of a specific substance, in this case for ethine. Okay, so C2H2, ethine or ethine. I've written out your complete and incomplete combustion reactions, and I'm going to post this on OneNote So you're using the first method of bond energies, and you're comparing the energy that is released for each type of combustion. And you're going to compare those values, and I'll post those answers on OneNote for you to copy down. For homework, there is practice questions on bond energies 5.3.